A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hello. We can easily count the number of coins in our hand, and like that we can exactly count the notebooks, etc. What about the leaves present in the trees around us? Can we count it? It is some difficulty in counting the leaves of trees around us. What about the sand in the seashore? Can we count the sand particles? No, we can't, because it spread infinity. Atoms, molecules are like this, spreaded like infinity. So, how we can determine the number of atoms and molecules present in a substance? Here you can see a 5 rupee coin and a sack of 5 rupee coins which are alike. Can you find the number of coins in the sack? It is difficult to count all the 5 rupee coins. The weight of one 5 rupee coin can be found as 5. We can also take the weight of the sack of 5 rupee coin and it was found as 50,000 gram. Can you count the number of coins present in the sack from this? What is the relation between the mass and the number? When the weight of one 5 rupee coin is multiplied with the number of coins present in the sack, the weight of the total coins present in the sack can be determined. We know the weight here. We have to determine the number of coins present. It can be found out when the weight of a total number of 5 rupee coins in the sack is divided by weight of one 5 rupee coin. That is 50,000 divided by 5 and it is 10,000. That means the sack contains 10,000 number of 5 rupee coins. Now we found out the number of coins present in the sack exactly. Like this, when the particles present are alike, its number can be counted on the basis of mass even though it is present in large number of quantities. Then how we can determine the mass of minute particles such as atom? It can be determined by a method, relative atomic mass. Okay? In the previous section, the mass of the sack of coin is compared to the mass of a single coin. Consider this situation. Here there is a weighing machine with 1 kilogram weight on one side and kept some fruits on other side. The needle of the weighing machine got balanced. Now here the weight of the fruits are calculated on the basis of the 1 kilogram weight. Can we found the weight of one oxygen atom using this? No, because it is very small. So, how can we calculate the weight or the mass of atoms? Here you can see carbon 12 atom. Let's divide carbon atom into equal unit. Here there is a weighing machine. Place one oxygen atom in one side and place the units of carbon 12 atom. What we can see here, the needle doesn't become balanced. So, add more and more carbon units here. When we place 16 carbon units on other side of the weighing machine, the needle got balanced. That means here the mass of one oxygen atom is equal to the mass of 16 carbon unit. Like this, the mass of sodium atom become equal to 23 carbon units and the mass of hydrogen atom become equal to 1 carbon unit and mass of nitrogen atom equals to 14 carbon unit. Okay. Here we divide the carbon 12 into 12 equal parts. So that consider the mass of one part as 1 atomic mass unit. Then instead of writing the mass of oxygen atom as equal to the mass of 16 carbon unit, we can write it as 16 atomic mass unit. Like this, mass of hydrogen equal to 1 atomic mass unit, mass of sodium equal to 23 atomic mass unit, and mass of nitrogen equal to 14 atomic mass unit. Let's look into the table. Element, atomic mass. Hydrogen 1, helium 4, sodium 23, oxygen 16, nitrogen 14. Each element taken with mass in grams equal to their atomic mass is known as gram atomic mass. That is, 4 gram helium means 1 gram atomic mass helium. 1 gram atomic mass nitrogen means 14 gram nitrogen. Then, how can we calculate the number of atoms present in the atomic mass amount of an element? We know that one pair contains 2 numbers. And if I said I have 1 dozen bangles, you can easily find out it is 12 in number. The weight of log in lorries are calculated in terms of ton. 1 ton means 1000 kilogram. So, pair, dozen, ton, etc. are used for the different measurement of different substances. Like this, measuring the minute particles, unit mole is used. Unit mole is used to state the number of minute particles present in an element, which is very difficult to find out. Like 1 pair contains 2 numbers, 1 dozen contains 12 numbers, 1 mole exactly contains 6.022 into 10 raised to 23 number of particles. 1 mole is equal to 1 gram atomic mass element. So, we can say that 1 gram atomic mass helium means 4 gram helium, which means 1 mole of helium atom, and it contains 6.022 into 10 raised to 23 number of atoms. That is, 1 gram atomic mass of any element contains 6.022 into 10 raised to 23 number of atoms. This number is known as Avogadro number and it is represented as Na. Okay. So, now you learn a new measurement which is mole. In chemistry, mole day is celebrated. In which day mole day is celebrated? It can be understood from the number 6.022 into 10 raised to 23. The mole day is celebrated in 10th month, that is October, and the date is 23. And the time is in between morning 6.022 am to 6.022 pm. Okay, then let's complete the table given here. Table. Element, atomic mass, mass in gram, GAM, number of atoms. Carbon, 12, 12 gram, 1 GAM, 6.022 into 10 raised to 23 number of atoms. Oxygen, 16, 16 gram, 1 GAM, 6.022 into 10 raised to 23 number of atoms. Nitrogen, 14, 14 gram, 1 GAM, 6.022 into 10 raised to 23 number of atoms. Chlorine, 35.5, 35.5 gram, 1 GAM, 6.022 into 10 raised to 23 number of atoms. So, any element equal to its atomic mass is called 1 gram atomic mass and 1 mole, and it's contain 6.022 into 10 raised to 23 number of atoms. Okay, can I ask you one thing? 1 gram of sodium means 23 atomic mass sodium, which contain 6.022 into 10 raised to 23 number of sodium atoms. What about 48 gram of sodium? How many GAM is it? And how many number of atoms contained in it? 46 gram sodium equal to 46 divided by 23 is equal to 2 GAM. Okay. Then it contains 2 into 6.022 into 10 raised to 23 number of atoms. So, When the mass of an element is given, we can calculate the number of GAM and the number of atoms present in it. So, number of GAM is equal to the given mass by GAM. Number of atoms equal to given mass divided by GAM into Na. And number of moles equal to given mass divided by GAM. Okay. So, 46 gram sodium means 46 divided by 23 equal to 2 mole of sodium. If number of moles are given, how can we calculate each quantities? Number of gram atomic mass equal to number of moles. Mass in gram equal to number of moles into GAM. Number of atoms equal to number of moles into Na. Okay. Then, if the number of GAM is given, number of moles equal to number of GAM, then mass in gram equal to number of GAM into GAM, number of atoms equal to number of GAM into Na. Then, if the number of atoms are given, number of moles equal to given number of atoms divided by Na. Number of GAM equal to given number of atoms divided by Na. Mass in gram equal to number of atoms given divided by Na into GAM. Okay. On the basis of these equations, there are so many problems are given in our notes icon.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.